Welcome everyone. Before I start the talk, let me say a few words about where you are. Who is first time is this at our office? We also a lot of people. Okay, cool. And I'm not just talking to one guy in the corner. So Container Solutions is a professional services company. We help other companies with their cloud transformation journeys, adopting cloud native technologies, moving from an old data center to the cloud, and all these kind of projects. We are a nice, small, not too small, like 80 people company, lots of place to grow. So if you're looking for a job in this area, feel free to visit our careers page. We hire more for what people want to do than their current skill. Will not grill you for your 10-year Kubernetes in production experience. I also like to describe what a average engineer at CS does as the warrior priest from role-playing games. We both spread the holy word and also do the work. So it's a bit of both. That's why we do conference talks and whatever, but we also actually code and get things working. Finally, we have our CTO and our CEO and Michelle have written a book about cloud native transformations. It's very nice. It's up on Amazon, and there is a free excerpt on our website if you are interested. And finally, we have a Cloud Native Computing Foundation ambassador in our group here who has kindly offered a 15% discount for KubeCon using that code. So whoever wants to buy a ticket to KubeCon, apparently it only works for corporate customers. How do you check that even?
Yeah, but
anyways, if they ask you, just write ING into the field of the...
and pay more.
Cool. That was for that. So the talk is going to be about Kubernetes operators and why they are the next frontier in application automation. Very important to say upfront that by frontier I mean a place where things are happening. It's not the place where everybody should immediately go to. It's where new things are happening. It's cool to watch. But it can be a scary place to go to. So I'm not trying to spread the word that like if you're not using Kubernetes operators, then you're in the wrong place.
No?
or you are.
Yeah, no. You don't. First of all, to understand what Kubernetes operators are. They are ways to extend Kubernetes to do things it doesn't normally do. But in this talk, I really want you to understand how do they work, because they're actually a very cool concept, and they are made around the core concept of how Kubernetes works. And that's very useful to also people here who don't use Kubernetes. I know everybody here is not using Kubernetes. So this is, you can think during this talk also about concepts, and those concepts can even be applied outside of Kubernetes, even if not that easily. But at least it's very interesting to understand. So Kubernetes works on the basis of YAML files. When you work with Kubernetes, you have lots and lots of YAML files. YAML files in themselves are not terribly interesting. What is interesting that you are describing your application's deployments to Kubernetes in a declarative format. So if you look at this nice YAML file here, this describes a deployment object which is running, which basically tells Kubernetes to run this Docker container for me with a certain amount of replicas. This is going to be an Nginx container running on your Kubernetes cluster. Yeah, one step back. Kubernetes runs Docker containers over a set of virtual machines. So it kind of hides away the infrastructure and creates a cloudy environment where you can just tell I want to run this application and it will run somewhere and you don't have to care about it. And then it provides a few services around that. So with a deployment object, you tell Kubernetes you want to run 3 replicas of Nginx 1.7.9 because that's the image that you specify. And what will happen inside Kubernetes in a little bit simplified way, because I'm skipping replica sets here. What will happen is that Kubernetes sees that you want that a deployment object with 3 replicas should exist on the cluster. And inside Kubernetes, a reconciliation loop, it's called a controller is the implementation of a concept called a reconciliation loop, which comes from control theory. So Kubernetes doesn't do the thing that Puppet or Chef does, where it just kind of, you got an input and now it runs, creates stuff, and then it's done. But what Kubernetes does is it constantly monitors its database for objects like this, and constantly monitors the real world for what's in the real world. And it is doing a reconciliation between the two. So first of all, when you create a deployment, what Kubernetes will do, it will see that on the cluster, 0 Nginx pods. Pods are containers for this purpose of this talk. We don't need to go into what's the difference between a pod and a container. It's container in Kubernetes terminology, if I simplify it. So Kubernetes will see that 0 Nginx pods are running, but the spec says that there should be 3, so it will spin up 3. If at this point you would create a 4th Nginx pod, Kubernetes would kill it, because 4 Nginx pods doesn't equal 3 Nginx pods. Also, if one of your Nginx pods happens to die for some reason, it will create a new one, because not because it sees that, oh, container is dying, I need to do something about this. Simply because of the fact that the spec says 3, it's 2, it has to be 3. Basically, this is a genius concept inside of Kubernetes, which makes your infrastructure very, very resilient, your applications, in a much more general way than as if it was monitoring all kinds of events and trying to react to events, and what do I do if it dies this way, what do I do if it dies that way. It doesn't matter. Keep the reconciliation loop running. That's what this is about. And this is going to be an important thing to understand how we extend Kubernetes. Another pattern, so basically this whole thing is, we can call it a basically design pattern inside Kubernetes. A slightly different version of this is when the controller actually modifies something outside of Kubernetes. So in the previous example, we were starting up pods inside Kubernetes. In this example, if you use Google's version of Kubernetes, the hosted managed version of Kubernetes called Google Kubernetes Engine on the Google Cloud, you have an option to create an object called an ingress. The ingress will tell the cluster how to route traffic from outside the cluster to your containers. Basically, you can see you can set like an HTTP path and say that something on /test path will go to the backend called test to port 80. Not very complicated. But this ingress thing will be on the Google Cloud specifically implemented using the GCP ingress controller, which will actually create a Google Cloud load balancer inside Google Cloud. This load balancer you could create by yourself in Google Cloud using the Google Cloud ways of creating stuff, the GUI or whatever other resource management. But when you're using Kubernetes, Google Cloud wants to make it easy for you to manage all your things from inside Kubernetes. So you don't have to like create a service in Kubernetes, but then go outside to Google Cloud and create this load balancer and then hook it up to your service, configure the ports in the right way and everything. It allows you to create this special Kubernetes ingress object, and then the GCP ingress controller will create the load balancer and configure it properly. And even route it back into Kubernetes, and actually under the ingress, the host name where your service is reachable will appear. So this is again an important concept for later. There is no rocket science to this, by the way. This controller just simply talks to Google Cloud APIs and creates this load balancer. So it's just, and this ingress object is not specific to Google Cloud. If you create the same ingress object on Azure Cloud, then a different version of this controller will create a different version of this load balancer, but on Azure Cloud, the Azure, whatever you need to do on Azure to make the same thing happen, basically. So controllers are not necessarily constrained to creating Kubernetes stuff. that's the, yes?
And how do I know which address, which URL should I go to reach my...
Yeah, so
service?
actually this, I should actually put that into the talk, good question. This ingress will have a status section, and the controller will, once the load balancer is actually created, will write the address into the status.
It will update the YAML.
Well, yes, once it's inside Kubernetes, it updates the Kubernetes database.
Not the YAML.
Well,
You
yeah,
can
not the YAML. So
query
that you, when you are like want to put in something into the Kubernetes API database, then you use a YAML file. But once it's in there, it's not YAML anymore. It's a document. It's etcd actually.
It's like HTML file and DOM.
Yeah, exactly. That's that. So yeah, so you would see the URL actually here. Yes.
I'm sorry, maybe a little bit unrelated. Is this one load balancer multi-regional resource? I mean,
I will not go into that. Yeah, that's too far out. Doesn't matter for the purpose of the talk. You will see where we are going with this, and not going to discuss the whether it's a. So now we're getting to building our own operators and extending Kubernetes. There are two reasons why. So what I will be talking about is basically there are these built-in deployment controllers and the GCP ingress control, all these things in Kubernetes. This is exactly the way how we can, if we write our own thing, we can extend Kubernetes. This will be what I'm going to be talking about. And the question is, why would we do that? There is two reasons. One is we want to manage third-party applications on Kubernetes. We want to run like MySQL or something. And in that case, this method of deploying stuff will compete with something like Helm. I'll explain that in a bit. The other reason why we would extend Kubernetes with our own things is to manage practically everything through Kubernetes. Kind of like the ingress case with the GCP ingress controller, where you could create that load balancer without Kubernetes, but it just becomes more convenient to do it through Kubernetes. So I'm seeing a few people are getting a bit lost there. So maybe one thing I didn't explain that well is that all these things are basically go into a document database inside Kubernetes. So the Kubernetes and they are accessible through a REST API. So everything I tell to Kubernetes to create, it all just gets dumped into a key value database. There is no magic to it until this controller process actually looks at that thing. It's just dumped into the database as static data. There is no other magic happening, and then there is an actual process running that will look at this data and do something with it. Does that? Yeah? Please raise your hand now if it's not clear, because we're gonna go deep now. Okay. So, managing third-party applications. Basically, there is a place called operator-hub.io. You can grab all kinds of operators that if you install on your cluster, they will manage these different types of applications. Usually, it's applications that are complex to manage. So you could just create a bunch of YAML files and install Cassandra on your Kubernetes cluster. That's fine. But for example, to upgrade Cassandra from one version to the next, that's a complex process that it's not enough to change the version of Cassandra in the YAML file, but there needs to be some complex process to happen behind the scenes, and these operators can actually make that happen. So these operators, these third-party operators, are for running stuff on your Kubernetes cluster. Many times stuff that, if you are in a public cloud provider, you shouldn't even run in your Kubernetes cluster, but just use the managed service. So this is not what I want to talk about, but I have to mention it because this is actually the main usage why people are developing operators to manage things like MySQL, clusters, and whatever. I want to talk about the use case to use Kubernetes to provision all your infrastructure. Let me show you an example of why would you want to do that. Here I'm introducing another interesting thing called GitOps. The idea that you put all these Kubernetes YAML files related to your applications into a Git repo run, whenever that Git repo changes, you run kubectl apply. Kubectl is the command line tool you manage Kubernetes with. The most important command it has is the apply command. And already see the whole declarative configuration idea here. You don't need to really create or update stuff. You just apply whatever is inside these YAML files, and all that stuff just gets dumped into the Kubernetes database, and then all those controllers start kicking in. It was 3 replicas before, now it's 5. I need to spin up 2 more pods. It was 3 before, but it's now 1. I need to spin pods down, I need to kill some pods. All this reconciliation loop stuff will be happening behind the background once kubectl apply happens on all your YAML files that are in your Git repo at the moment. And this is a very, very good way to manage your infrastructure. And this is possible because Kubernetes is fully declarative. There are no commands to like create this, update that, or whatever. There actually are, but you don't need to use them. kubectl apply, all your YAML files, create stuff inside. These are, let's say, objects inside Kubernetes that get created from those YAML files. Now, let's say you're on AWS and imagine you're the infrastructure platform team. You want developers to be able to do their shit. Because whenever, maybe that was not the correct. I'm a developer, by the way, so I'm not saying that as a not nice thing about developers. So right now, developers can get their Docker containers running on your cluster by just committing to this Git repo. This process will run everything, runs beautiful. But developers also need like databases, let's say. And what happens then? They come to you, they send you an email to create them an Aurora DB in AWS, give you the credentials and so on. You would like them to have an automated process for this. Now you can either set up a completely different process using Terraform or CloudFormation or whatever, or you can make it happen that they actually can create an Aurora DB YAML file inside their Git repository. Using the same way as they manage all their other stuff, give them an option to create Aurora DBs also with Kubernetes objects, Kubernetes resources. What will happen in this case, kubectl apply will create an Aurora DB resource inside the Kubernetes database based on that YAML file, and still nothing will happen inside AWS because Kubernetes allows you to create a special Aurora DB resource. These are called custom resources. Basically, you define a schema for a different type of resource that Kubernetes doesn't know until now, and you dump that into a YAML file that gets applied to the cluster, and the objects get created in the Kubernetes database. I'll be showing everything in a live demo, by the way, so that will make things a bit more tangible. But once you create an operator, your own custom code running inside a pod in Kubernetes that is watching the Kubernetes API for these objects there, specifically for the object of type Aurora DB. And you can put code into this operator, write it in whatever language you like, that will talk to AWS and actually create an Aurora DB based on this object inside there, and then probably put the address and the credentials to this database back there, and then applications that are running there can use it. So what we're trying to do here is create a unified interface for development teams to access all the services that they can use without having to have special paths for creating the database, a special path to create a Kafka topic, etc. Everything can happen just using these YAML files, so you have one unified continuous delivery workflow. That's the whole goal here. And this makes sense, especially at larger scale, to have a really unified, because every edge case will get you too much work. It's also very expensive, so I'm not advocating this as a thing to do in every use case, and for, let's say, a small company to start writing operators to like create a few things that they maybe need 2 Aurora DBs altogether. You don't want to create an operator for that. So what let's look inside this this operator. What does it really do? On the left hand, we're getting rid of YAML files. We are now just talking about the Kubernetes API. We have custom resources. We first have a schema for AuroraDB. I should have probably shown here a bit of YAML that would have made it more tangible, but I will be showing some later. We create a custom resource definition that will tell Kubernetes that this is AuroraDB is now a thing. Then we can create concrete AuroraDB custom resources that adhere to that schema. Let's say they have a name, an encoding, whatever you need for a database, size, I guess. And there is this operator process running on the cluster. It's running in a completely standard pod. There is nothing special about this process. It's as every other pod. You actually create a deployment object to start this up and all that stuff. It creates a watch using some Kubernetes API client library. This is a REST API, so there are client libraries for it, but you can also access it with just whatever REST client. Also, it's pretty complex, so client libraries are heavily advised. It will be watching for any events happening to any AuroraDB custom resources. There is the controller runtime that will manage these events that are coming in, order them, drop some if like there is a delete event, any other event that's coming after that is probably not interesting. And then comes your code that does the business logic of what happens when I see a new AuroraDB there, what happens if AuroraDB in the Kubernetes API gets deleted, what if an AuroraDB in the Kubernetes API gets updated. All that logic is in here in this controller layer, and then there is a client library layer that actually talks to AWS and actually does the real thing happen. What's important to note here, that this part can be encapsulated in a framework, and it is encapsulated in a few frameworks for a few languages, including one that I made for Java. But the main thing is for Go, by the way, so the main language of building operators is Go. This part, the controller, on the other hand, is pretty hard to write. You can imagine that all that magic that is happening of upgrading, deleting, creating databases, all that stuff needs to go in here, and you have to just write it. That's the not nice thing. That's why operators are just a design pattern to do things in a certain way. They don't do any magic for you. All the hard stuff remains hard. If people created the MySQL operator, they had to deal with all the crap of like managing a MySQL cluster. But once it's done, then once it works, it works. Yes?
So this watch thing that you have to do, how much overhead does that create on your Kubernetes cluster? I mean, if you got many of them, I can imagine what it's doing is calling,
So yes, if you create the AuroraDB operator, so the question is, I guess how many watchers would exist in a cluster, right? And how do they interact? And
how crazy can I go with them if I have hundreds of them? And do I now need to scale up my cluster?
So if you create an operator for AuroraDB, let's say, I would say you run only one of them for your whole cluster. There is no real way to parallelize this work that is happening here. The Go library actually allows you to run multiple instances, but they just do a leader election, so it not really helpful in that way. So in that sense, you can't. They just for resilience, not for scalability. And actually, with an operator, you don't need resilience that much, because if it dies, that just means events are not processed for a second or two until it gets restarted and it's working again. So you will not have hundreds of watches. You'll have different operators handling different types of objects. So let's pray to the demo gods and start the demo. I will be showing this AuroraDB scenario, except I don't have a Git repo. I'll just have a directory with YAML files, and I'm not doing AuroraDB, but I will be creating schemas inside the MySQL database, which might sound not realistic, but actually in a company where people are managing databases, like it's not using some AWS managed RDS something. It is, I think, a very good idea to do things this way, to allow developers to create new schemas, new databases inside an existing database cluster. Give them that level of freedom. So, let's see. First of all, I need to make the fonts work, which I didn't done before, but let's do it now. Is this big enough? Also, maybe I should pull it higher, right? Good. Let's clear it. Wish that wasn't so long, but I have no idea how to disable that. And I'll grab a chair because this is really convenient. Okay, so first of all, I have a Kubernetes cluster here that I'm managing with kubectl. It's running on my laptop using Docker for Mac. It's a really cool tool if you want to do Docker stuff on Mac. Doesn't just run Docker, but actually runs the whole Kubernetes cluster on my Mac. Kind of drains the battery, so I don't keep it running all the time. I can look on Kubernetes and see a bunch of namespaces. Namespaces are kind of like projects. They isolate whatever is in them. I have an Adam test namespace, which I will now delete because that was the tool I'm using is kubectl or kubectl, or there are different ways people call them. The correct way to do it is kubectl. I delete my previous test namespace, which deletes every object that I had inside it. So everything I'm creating on Kubernetes, there's always a namespace added on which namespace am I creating it. And more importantly, I have a MySQL namespace. You can see that here. That's where my MySQL database is running. In this case, the MySQL is running on my cluster. I can look inside there, say kubectl get pods, namespace MySQL, and you can see that a MySQL pod is running here. With my MySQL workbench, I can actually connect to it. You can see I'm connecting to localhost 32057. That's running on my machine. And you can see there are no schemas inside my MySQL database at this point in time. Okay, so we have MySQL. Second namespace you can see here is the MySQL schema operator namespace, where the operator is running. I could be starting it up, building a Docker image out of it and starting it up in front of your eyes, but I'm not brave enough, so it's already running. Get pods in MySQL schema operator namespace. When I write K, that's the same as kubectl. And you can see the MySQL schema operator is running. Seems like I was 52 days ago on a conference in Warsaw. Okay, so this is running. I can actually take a look at the logs from it. I'll do that in another tab so we can keep watching the... Oh, shit, no, it's making the window bigger. I have to create a script for this or something. So you can watch logs in the namespace MySQL schema operator for the pod. And you can see there are some messages when I was testing just before the talk at 4:41. I was creating a schema and deleted the schema myDB, and this is what we're gonna do now. So let's just do it first. Let's see that it's working, and then I'll show you what's exactly happening behind the scenes. So first of all, the things I didn't show you yet is custom resource definition. This is the resource definition for MySQL schemas, where I'm extending MySQL, the database, with something new that it didn't know before. So before it wouldn't have allowed me to create MySQL schema objects in the database, but now it does. For example, now I can do this, kubectl get schema. And it says there are no schemas because I didn't create anything yet. But before I would have applied this custom resource definition to my cluster, it would have said, like if I say schema, then error, this type of resource doesn't exist, right? So now I have created for the API server, I have created a new type of object. And I can say things like what is the plural name, it's schemas, so I can say schemas. And I can give it a validation schema where I'm saying the only property this thing will have is encoding, and it will be type string. I couldn't come up with anything reasonable, but MySQL schemas come with an encoding. It automatically has a name, it always has a name, so that is not a special property. And out of this custom resource definition, here is my MySQL schema. Its name is MyDB, and encoding is UTF-8. And it's of kind MySQL schema, and this kind is defined, right? So here, kind is MySQL schema, and it is defined in the spec of the custom resource definition. So I'm referencing this like a schema or like a class and creating objects from the class. So now I will create a new namespace. CD meetup. Go into that name. I will switch that to a default name to be my default namespace. Yep. And I will apply this YAML file. So now I'm not doing the whole GitOps thing I was showing because I don't have a Git repo here and whatever, but you can imagine that the whole Git repo thing was just about doing kubectl apply on all the YAML files. All the YAML files in my case is this one YAML file. So I'm doing kubectl apply f, it's in the crd directory / example YAML. So I'm going to apply this one. Bam. At this moment, probably our database is already created, but it's not instant. So at this moment, what kubectl does, it inserts this object into the database. If my operator is running, it will actually create the schema inside MySQL, which it should have done. Yay, we have it. But if it wasn't running, nothing would have happened. I'll show that. So I will now delete the schema. And the operator kicks in, and the schema is gone. But if I kill the operator, I hope I will be able to start it up again. Delete in the namespace MySQL schema operator, the deployment MySQL schema operator. Bam, it's dead. So now I can kubectl apply f crd example YAML. You see everything created, beautiful, nothing, no error reported because it's a nice distributed asynchronous system, but nothing is happening in my database because the actual process that would do something with that object in the Kubernetes database is not running. So I can get schema, we can see it's there, but nothing is happening. As long as I restart my operator, which I have completely deleted from Kubernetes now, so I will recreate it by this YAML file. I will show you the YAML file so it kind of feels real. Here is the deployment for the schema operator itself. So it will run an image called MySQL schema operator with a single replica. And the interesting part here is that as in the form of environment variables, the operator gets the credentials to the MySQL database, right? That really shows that it needs that stuff, otherwise it can't create schemas inside the MySQL database if it cannot access the MySQL database in the first place. So in the case of the Aurora DB thing, it would be credentials to AWS APIs. In this case, it's just credentials to the locally running, like the host is MySQL, because on the cluster you can access it under that name. So now that I restart it, it should be running, and we should soon have this schema if everything goes right. Oh, and how much time do I have?
How much time do you want?
I don't know. An hour plus, one more? I'm going to the framework and I'm gonna be done in like 5 minutes. Oh, there we go. MyDB has appeared again. So you can see the operator started up. Thank you. It immediately picked up all the objects that were, because now the schema object in the API server was created before the operator would have been running, but that's not a problem. The operator just looks at whatever is in the API server and just acts on it. It doesn't care whether it has been created before or later, whatever. It just looks at the current state and reconciles that with what it sees inside MySQL. So that's how the operator works with a new type of custom resource. This is how I can provide to my developers a new type of thing they can now play with, use, without them having to send any emails to me, or without me having to do this with Terraform or something, some completely other way. But what's happening inside the operator is also very interesting. So let's just close this stuff, and I think I'll try to set the font bigger because that will be much. Oh, wait, IntelliJ has this presentation mode. Let's try it. Ooh, this is always my problem, that then it becomes too big. You go from too small to too big. Anyways, so here on the left side is my MySQL operator source code. It has a Docker file, so it's just packaged as a normal Docker image. It's run as a normal process on Kubernetes. There is nothing special. Kubernetes actually doesn't know about your operators, even though they are the extension points to Kubernetes. It knows about the special custom resource. I have to register that. But then the process that is actually doing something with the resource, Kubernetes doesn't care. So this is written in Java because I like Java, and because we had a client where everybody was Java developers, so we even created a little open source framework for helping create operators. I'm not going to be showing the framework, I'm just going to be showing the client code that actually does the logic. That becomes very simple because of the framework. The framework does a few fancy things in the background. So here we go. Schema controller implements resource controller. It works with MySQL schema from the group MySQL sample Java operator SDK. Those who don't work with or like Java, is there anybody who works with and likes Java, or like uses Java at least? Okay, a few people. I'm looking for contributors to the framework. Really cool work. Get in touch. So what happens inside this controller are two main methods are interesting: create or update resource and delete resource. So creating or updating the resource, what happens in the code? As a parameter, we get the schema object. This is a Java class that basically represents all the stuff that's in this schema YAML file. Example YAML. So that's a Java class that just represents the data from this example YAML. We can see that it's schema. See, it has a spec, has a status. Yeah, we also have a status, by the way. Once but I think the URL doesn't actually work. If I would know how to go back, yeah. Yeah, and then the spec has inside it the encoding, but we will see. So it's nothing fancy. It's just a class where we can map the actual data from the Kubernetes API. So we're not mapping the YAML file, we're mapping the data from the Kubernetes API server when we receive that event that we have seen on the slide. So we get an event that something has happened to this schema resource, and then we go. We connect to the MySQL database, and we check whether we execute this select, whether that database already exists. We get the database name from the schema object, from the metadata, from the name. I will actually go to the command line and get this stuff from here. This is exactly what we get. Get schema and in YAML format. Oops. So you can see now, like there is a bunch of stuff added by Kubernetes also, but you can see it has a name. Kind MySQL schema has a name. It's in some namespace. There is the spec with the encoding, and actually we have a status. Oh yeah, and even the URL. You see, these things the operator will be setting on this resource after it has successfully created the database. So if I go back, if the database doesn't yet exist, then I go to create schema with the character set, also grabbing that from the schema, from the spec, getting the encoding. Then I'm updating the status that I've just seen, setting the URL, setting the whatever name, setting the URL, setting the status to create it, setting the status on the schema, and then returning the schema from this method, and the framework will take care of updating it. So, or I get a SQL exception, and in that case I set the schema status to error and be done with it. So this is pretty much, and if the database already exists, then I don't do anything because we don't do any update operations here. Let's say I could be fancy here. What if the character encoding changed in the schema object, right? I would probably destroy the database and recreate it, or maybe there is some upgrade process in MySQL. If that exists, I could create that here because this branch in my code does whatever needs to happen when something changed and is not a create operation. And then comes the delete. And unsurprisingly here, we just drop the database and do the delete. So these two methods are managed by this framework. If I go back to my slides a little bit, here, right? So this part is a Kubernetes framework for Java that's called Fabricate Kubernetes Client that we use. This is the framework, the Java Operator SDK framework that we created. This is the code that you have seen, and this is the MySQL client library code that you've also seen in this demo. And that's it. Yes, I'm done. Ask questions rather than me going on.
If you want to store something, for example, you have two these operators and like you want to store the boolean flag that schema already created. Can you use etcd from the operator itself, like store something in etcd?
Yes.
Yes,
You
so
can,
it's possible.
because the operator is running on Kubernetes, it's already talking to the Kubernetes SDK, it can Kubernetes API, it can actually store its own data. Usually what the preferred method is that custom resource will have all kinds of fields where you might want to store something about that particular database, because whatever you want to store is probably something related to that particular database, not in the general.
So you storing the resource from inside of the Kubernetes operator, just programmatically.
Yeah, you can modify stuff on the. But usually you're not really supposed to do that. That's a very edge case when you need to like really talk to the Kubernetes API, because the framework takes care of it. If I change anything in that schema object, I return it from the method and the framework saves it, and that should be the usual flow of information. You should not from the operator really like do some other stuff in the meanwhile. Unless you're creating some Kubernetes objects like pods or something, then you actually need to talk to the Kubernetes API.
Yes, okay, thank you very much.
Yep. Yep, I think you were first.
It doesn't matter.
Oh, go for it. Okay.
So you showed before that you had in one of the files that you would store in Git, you had some secret, some variables, or some database password. What's the standard way of dealing with not putting those things into Git?
Right. Yeah. So you doing the GitOps thing that I was showing here. Yeah. You wouldn't put secrets in here. Well, you have two ways. Either you put secrets here encoded, and then there is, let's say this is Jenkins doing this, and then you have a decryption key in Jenkins that can decrypt those secrets, but it's not the best way. One simple way is just Kubernetes itself has secret management capabilities. You can create secret objects inside Kubernetes, which you would not manage with this Git repo, but you would create them straight either kubectl, or use a more sophisticated solution. Sorry, the camera is still beaming into my eye. Or you would use a more sophisticated solution like HashiCorp Vault, that is like a centralized secret management thing. I just read some news that they actually finally integrated it with Kubernetes, so you can create Kubernetes secrets from what's stored in Vault and so on. So this is more for the non-security stuff.
Maybe I can add to that. Some operators, they also generate their own secrets. So when you deploy it, it creates a secret, and then you use a secret in another part. That's also.
Yeah, in this case it could be completely, because like the operator knows the credentials to the MySQL database. Actually, your application that would be consuming that database that has been created, we didn't go that far to have an actual application that would actually consume that. But what might happen is that you would, it definitely would happen that your application also needs credentials to access that database, and the operator could exactly put those credentials as a secret next to your application in Kubernetes, and then your application could consume them. Yeah, good point, Bart. Thank you. Yep.
So my question, it's clear how this works with databases. I'm curious what other applications, either useful or ridiculous, this has been applied to. Because I could see somebody controlling their Spotify playlist this way, or their smart home lights or something like that.
Yeah. Or tweet through the Kubernetes.
Exactly.
Pizza operator.
So what I could say, queues like messaging systems like Kafka, for example, there is an operator for Kafka that will create topics and everything in Kafka based on custom resources that you create. Very useful because you can run one Kafka over the whole cluster, and everybody can just create these custom resources and get their topics and queues and whatever in Kafka. And what we did with operators, which is maybe not the perfect case, but we provision more like internal infrastructure, CI/CD infrastructure using operators. So you can create like a custom resource called Jenkins, and then you get the Jenkins with like a deployment pipeline and everything pre-configured. That's in that case you don't really get this GitOps workflow, because actually those things are not really. Doesn't matter, I'm not overcomplicated, yes. I think any kind of like internal infrastructure stuff could be useful to be created in this way in many cases, not saying all, but in many cases where you have to write code to provision some infrastructure, especially for some reason Terraform would not be enough, which actually can be many reasons why Terraform would not be enough in many cases. So,
Good. Thank you.
Once?
Everything where you can put as a service, as a postfix, you can create an operator, essentially. Because when you deliver it as a service, you know how to do this shit, and you can automate it. Because you tend to be lazy and don't want to deal with, oh, I'm gonna build this for you, blah blah blah.
You mean like anything, any kind of service delivered by infrastructure platform
everything,
team could
if
be
you have
an
like,
operator?
You mentioned Kafka as a service.
Yeah. Oh,
and
yeah,
someone you have in the company, you probably have Cassandra as a service.
Yeah.
Or whatever you can think of as a service, you can essentially put in an operator.
Yeah.
Is my
But
personal opinion.
all this kind of going, like pulling everything into Kubernetes makes sense.
Except
The base
when you create a
scenario
service.
is that you are heavily using Kubernetes in the first place, right? So it's like, let's say you're running in VMs on AWS, don't start writing Kubernetes operators, there is no point.
That would be fun. Deploying VMs with your operator.
Actually, yeah. Yeah. So, yeah. Any other questions? Yes?
So, what's your thought about Helm versus operator? Is there?
Yeah, that's a very good question. So,
Easy.
Helm is a tool that does a bit more than what kubectl apply does with the YAMLs here. Helm can do templating and bit of logic of pre-processing the YAMLs, and then it also has some like release management logic on the cluster that whatever it deploys, it actually tracks what has it deployed, and that helps in certain scenarios. So Helm is a very preferred deployment tool on Kubernetes. Many people don't like it, including me, but it is a very popular deployment tool. Now, why would you use, let's say, and there is, let's say, a Helm chart, and Helm, the like YAMLs are called charts. There is a Helm chart for MySQL, and then there is an operator for MySQL. Which one should you use? What Helm cannot do and an operator can do is the whole dynamic logic of, let's say, upgrading stuff in a fancy way, of like, because the operator is just code where you can do anything, and Helm is just modifying YAML files in Kubernetes in the end, because the end result of the whole process is that your object in the Kubernetes API server will be modified, and there is not much place to plug in any kind of logic. So that's why also third-party operators are usually used for stateful complex applications, because that's where you need that extra logic. But in this database case, this is not very complex logic that we needed here, but it is special logic that is like Helm can also only modify Kubernetes. So anything you need to like provision outside Kubernetes, Helm will not help with that. So both these cases have their merits against Helm.
Thank you.
Not saying that you should stop using Helm and just write operators.
You can actually, in Red Hat Operator SDK, you can convert a Helm chart into an operator. I'm not saying it's a very extendable operator, but
Yeah, you just kind of package. That's really just going from like same functionality to doing the same thing in a slightly different way. That's yeah. Yes.
So with Helm, and of course even without Helm, with just straight Kubernetes, you can, I can't remember what they're called, but you can run it like a startup container that would handle some of this logic for you. But I understand it's not quite as flexible as this. Is that the biggest reason not to do that?
Yeah.
Okay.
Yeah. And also some more reasons, but like there also the pool model that like no, actually no, that's too deep. No, that's this is much more flexible. But then there is also people packaging Terraform, let's say, into an operator, right? So like you have well, it's like you already have some Terraform stuff that can create an Aurora DB, kind of logical to like put it into the operator and just kind of translates from the Kubernetes object to the Terraform.
It's a way to get job security. Nobody will understand it.
Yeah.
And then you would have 2 states instead of 1.
Yeah, they would store the Terraform state from the Kubernetes API server.
gross.
All right. Well,
If I understand right, operators compete with Ansible roles in a sense.
maybe I have no idea what Ansible is.
It's not tower, maybe.
So there are Ansible. You probably know what Ansible roles.
I know what Ansible is, but I don't really know it. So I don't know what roles are.
So I was just thinking, is it possible to get rid of Ansible altogether and just converge on Kubernetes?
Yes. Depends on what you're provisioning with Ansible. So like if you're like, I really don't like configuration management tools, basically because of the whole concept of them, how they work. So for application deployments and stuff, I would definitely just do Kubernetes. You don't even need operators for that. You will be already in a better place than using Ansible to install stuff on VMs or something like that. Does that make
But
sense?
sometimes you need a sequence of steps, right? And
That's what you should not.
that's
So
one.
that's what you should not need. That's why I don't like configuration management tools, because the only place where you're allowed to do a sequence of steps is when you're creating an image. In that case, you theoretically might even use Ansible to create a Docker image. You could run theoretically Ansible inside the Docker build process. You wouldn't want to do that because it's usually useless. But when you're provisioning stuff, you should be creating an immutable image, and when you're deploying stuff, it's already an immutable image, so there are no steps anymore. Tell me who disagrees. Go for it.
Can I?
We provision namespaces using operator, and it's kind of hard to do airbag of create role bindings if the namespace is not there. So sequence of stuff sometimes needs to be there.
Can I add to it? So
Okay.
the operator kind of crystallized the logic behind whatever you want to install.
No.
We have somebody from CloudBees here, so there's a Jenkins operator that creates a Jenkins server, and that's a sequence of steps,
Okay, that's true.
right? So, but the logic, you don't need to know how to install Jenkins, but
No.
because the operator knows that somebody solved the problem for you. So that's
I
That's-
understand that inside the operator you can have a sequence of steps.
Yes.
But what if a sequence of operators is important for
When
you?
you create an operator above it,
Of
and
operators.
that will do all that shit for you.
Yes.
you
Well, I
create
actually had a
more.
slide about exactly that scenario, but I ran out of time.
not ready.
Maybe I can show you, like, but yes, we do have, we created the CI/CD thing with, somehow I always end up showing this, even though I always want to skip it. So we want to create CI/CD teams, like teams with CI/CD capabilities, and we create a team object in the API server, just a team that says the name of the team, and they need a test for 2 production environments and whatever. And then the team operator picks up this team and creates a whole bunch of sub-resources from it. Each of them, like the Jenkins, the deployment pipeline, Bitbucket repositories and stuff that they need. and all those are handled by other operators, and these create then the actual objects in the real world. And basically, so the team operate, and actually these cannot be created in any order. So that team operator will be creating these objects in a certain order, waiting until the real world object actually gets created, then creates the next thing, and so it does that orchestration of like the ordering of things. So I was wrong about saying the ordering is a bit more complicated than that, but yes, I'm showing this again there.
Thank you.
Yeah, if there are no more questions, then maybe let's move on to the next talk or the drinks or what comes next.
If there are no questions, then
Yeah, thank you very much for listening, guys.